Before we start this lecture, I have to mention that this video's content is basically taken from the Flutter Performance Profiling and Theory presentation from GDD China. So this is an excellent presentation done by this person over here. And if you do happen to speak Chinese, then I definitely recommend this video. Or if you do not mind reading the subtitles or the auto-generated English subtitles. Some of it doesn't translate well, so that's part of the reason I do not feel too guilty about stealing the content, but the entire structure of how he explains the rendering pipeline was done incredibly well, and I basically took it and just explained it in my own words, and at a slower pace with a couple of extra descriptions. So if you like this lecture, do not give credit to me, give credit to the people that did this presentation. In this lecture, we will take a look at Flutter's rendering pipeline. So we will take a look and see how Flutter takes its widgets or its widget tree and then finally lays them out to the screen. So we will explore the steps between a widget that we define in code and then the Flutter framework rendering it to the screen. And we will mostly discuss the areas that are of concern to us as Flutter developers, or the areas that we have control over. In some ways, if we define a widget, then the Flutter rendering actors manages the layout and the painting on our behalf. We simply create a widget and then Flutter renders it. However, there are ways that we can control part of this process to sometimes improve performance. So if we break the timeline up a little bit and take a more detailed look at all of the different phases that are responsible for rendering, we can see that we have our build phase, layout phase, and paint phase. And then finally, all of this basically generates a display list that will then be rasterized by the GPU. So the GPU will display it as an image that gets rendered to the screen. So the build phase is the phase that we as Flutter developers are responsible for. This is the rendering phase that we control the most, as this is where our widgets get rebuilt and the subsequent elements for those widgets get inflated. And from those widgets, we also create the relevant render objects for the widget. And this is where we head into the layout and paint phase. And the framework manages this, so we do not have to worry about layout and painting. For example, if you create a text widget, then the framework will manage the layout and the painting of the text to the screen. However, as we will see in later lectures, there are certain aspects of this that we can control. But before we delve into that, we need to start at the beginning. And for us as Flutter developers, the beginning point is probably the widget tree. So as you can see, the blue tree to the left, that is a representation of the widget tree. And then you can see for the widget tree, we have an identical element tree, or at least it has the same number of nodes. And in the render tree, you will see that we actually have fewer nodes. And that is because some widgets are in fact only components and they do not create a render object. And then finally, the yellow node at the right is our final display list. So basically our final image that will be rendered to the screen. If we were to group this using Flutter's threads, then the build, layout, and paint would be the UI thread, and the display list to the GPU would be the raster thread. So let's define this a little bit more and incorporate some code. So to the left, you can see that we have a container that is blue and a child that is a row with an image and a text as children. And in the widget tree, you can see how we branch out and create the relevant widgets. So one thing to note is that the dark blue nodes, those are the widgets that we added to our code. However, a container would actually be a decorated box. So without us needing to, Flutter will actually create a decorated box once we create a container. And the same with the image and the text. If we add a text widget to our tree, that will finally be a rich text. And if we explore the element tree that is created from this widget tree, we can see that some of the widgets will in fact create something that is called a component element, and others would create a render object element. And the definition for a component element is an element that composes other elements. So rather than creating a render object directly, a component element creates render objects indirectly by creating other elements. And a render object element is an element that uses a render object widget as its configuration. And a render object element has an associated render object widget in the render tree, which handles the concrete operations like laying out, painting, and hit testing. So if we go back to our widget tree and take a quick note of the different widgets, we can see that these widgets are representative of different types. For example, a container is a stateless widget, while a decorated box is a render object widget. And as we read before, a render object element uses the render object widget as its configuration. So what this basically means is that this is a widget that will be rendered to the screen, and not just a component that lays out other widgets. So the element tree can also define stateless elements and stateful elements. And in a later lecture, we will explore this a bit more. But the core thing to understand is that if we create a stateful widget, that state is kept by the element, or at least the element tree manages the state for that particular widget. But as I said, in a later lecture, we will go into more detail regarding this. For now, just understand that depending on the widget, a different element might be created. To define this even more, some render elements can be a single child and some can have multiple children. For example, the container has a single child while the row has multiple children, meaning the row can have multiple different render objects. And this is where the core part of the element tree comes in. The element tree is responsible for parent and child relationships. Our widget tree actually doesn't care about who its parent or who its child is. The widget tree is purely just there for configuration. And then finally we have the layout and painting phase. And as I said, that is managed by the render objects. So depending on the widget, a different render object may be created. For example, in the case of a decorated box, we create a render decorated box. And a row will create a render flex, while a text widget will create a render paragraph and the image will create a render image. We should take note that the element tree is responsible for keeping track of the widget tree and the associated render objects that is attached to each widget. And then finally we have the layer phase. So what happens is at the very end of our build, layout, painting, and then compositing, Flutter finalizes the render tree, so the tree that needs to be painted, and then it takes that tree and it sends all of that information to the raster thread. And those painting instructions are what is called a display list. And a display list is a series of graphics commands that define an output image. So an image is basically rendered from a series of commands. So these are painting instructions that will be executed by Skia. So that is how we finally get the last layer, which is the picture layer that we can show on the device. So that is a quick overview of how Flutter takes our widget tree and then finally creates an image. The question now is, what happens when we update the widget tree? So here we have this example where we call setState and we update the text value from A to B. And the first thing that we need to take note of is the fact that widgets are immutable, meaning they cannot change. Once a widget is created, it is final. So if we want to update our widget, we need to create an entirely new set of widgets. And in this particular instance, that would mean that we are recreating the entire widget tree. So we can discard the entire tree we had before that, and we create an entirely new tree. However, it is different for the elements and the render objects. They are mutable, so they can change. The only question now is, when do they change or how do they change? And how all of this is managed is by the elements or the element tree. So we know that an element is an instantiation of a widget at a particular location in the tree. And each element has a update child method. And that is a method that updates the given child with the given new configuration. So when we recreate our widget, we get a new configuration. So basically we are updating our element to point to the new widget configuration or to the new widget. And for a component element, this happens in the update method, and this just changes the widget used to configure this particular element. So the framework calls this widget when the parent wishes to use a different widget to configure this element. However, an important point to note here is that the new widget has to guarantee to have the same runtime as the old widget. And this is where a large part of the performance comes in, because that is the first thing that Flutter does. It checks to see if the old type of the widget is still the same as the new type. So for example, this particular component element is a container. So if we replace this to be a completely different widget, for example, a size box, then that would not be of the same type. So that would actually result in us discarding the entire element tree and all of the widget's associated elements being recreated. And as a result, Flutter will also recreate the associated render objects. However, in this instance, all we are updating is the text value. So the container doesn't change and the row doesn't change. So Flutter will reuse all of the elements and render objects as much as possible. So after the widget that configures the elements has been updated, we again call the update child method. So now we will go down the tree, and this time it's a render object element. So that is different to the component element. This is an element that uses a render object widget as its configuration. And again, we call updates on this, and that again will change the widget used to configure this particular element. However, this time it's slightly different. Now the widget will actually call the update render object method. Because this widget will actually create a render object, we also need to see if we need to update the render object that is associated to this widget. And the description for the update render object is that it copies the configuration described by this particular render object widget to the given render object. And now the question is, should the render object update or not? And again, Flutter will try to be smart about this. If nothing in the associated render object widget changed between the last configuration, then it's not necessary to actually update the render object. So for example, in our previous state, the container had a color of blue, and it still has a color of blue. So in this assertion or this if condition, we can see that if the value is still the same as the previous decoration, we just return and we do not update. And at the bottom, you can see there's a call that says mark needs paint. And in a similar way, all of the other elements and render objects will be tested to see if their types has changed or if any of their configurations has changed. So the framework will do the same for the row and then the image. And then finally, if we go to the text, that is where we can actually see a difference. So in that instance, the render objects will be updated to change the text value from A to B. And then finally, we generate the layer that will be sent up, and then that layer can be rendered to the screen. The main point to note here is that Flutter tries to reuse as much as possible. However, as Flutter developers, there are a number of things that we can do to guide the framework to make smart decisions. And we will briefly discuss them here. However, they will be discussed in great detail in the upcoming lectures. So imagine we have the current tree layout such as this, and then we make a small change in some part of the widget tree. The only two widgets that actually change are those two bottom ones. So what we want to do is, instead of rebuilding the entire widget tree, we want to containerize our rebuilds. And this basically means that we only change the state for a small subset of our tree. And we do this by having small build methods. So instead of having one very large stateful widget that returns every single widget in your application, you obviously create separate different widgets that manage different things. And if only one widget needs to update, you don't want your entire widget tree to update. And for this, there are a number of different ways that we can contain our rebuilds, which we will take a look at in a lot more detail in upcoming lectures. And then for the element tree, if we only change a part of the widget tree, then only a part of the element tree will be updated. So instead of going from the very top of the tree all the way down and updating everything and changing all of the configurations, we only do that for the necessary part that we know has changed. So again, this is why Flutter is performant, and another instance where Flutter is smart about updating its render trees. And we can manage this more by using keys and making sure that we are using the same types. So not changing our widget tree to have different types at different locations in the tree. And by types, I mean not switching a container for a size box without having a reason to do that. And then finally, we head on over to the layout and paint phase. And when it comes to layout, we are in some ways constricted, or not constricted, but I would rather say that we do not need to worry too much about the layout phase. The framework does a good job at deciding when widgets should be relayed out again. So for example, if we have a container and the size changes, then that will result in the layout performing the size update. While in the paint, there are a couple of things we can do to containerize our repaints. Because by default, Flutter introduces something that is called a repaint boundary at the very top of our tree. And if we perform a repaint in one small part of the tree, it will result in all of the widgets updating that are within that repaint boundary. So if this is a simple application and nothing too intensive is happening painting wise, then this is definitely not an issue. However, when complicated painting operations are performed or complicated layouts or animations, then it might be a smart idea to introduce our own repaint boundaries. And again, we will cover this in great detail in upcoming lectures. And finally, we will have our different layers or our different display lists that will be sent to the GPU to be rasterized. So now that we have a good overview of Flutter's rendering pipeline and what widgets, elements, and render objects are, we can finally delve into doing some actual performance improvement and taking a look at some actual code. So in the next lecture, we will start taking a look at some practical examples.